All right, we've got a good number of you rolling in now. It's 11 o'clock. I'm conscious of time. We've only got half an hour, so we will formally start now. Kia ora, my name is Tegan Jones. I'm Brand and Communications Manager at Manaaki Whenua. And I'd like to extend a warm welcome to everyone today who has joined us for our first Manaaki Whenua Link Online webinar for 2025. A really great program lined up for this year, and today's topic is a fantastic starting point. Our presenter today is Dr. Joe Kavanagh, our Acting Portfolio Leader managing land and water, land use and ecosystems. The research Joe will share with us today is a cross-CRI project funded by the Ministry for the Environment and is focused on revision of target ranges for soil quality indicators used in State of the Environment reporting. Provisional target ranges were originally developed in early 2000 and published in 2008. And while there has been some review and revision to these, a substantial amount of additional soil monitoring, reporting and research has been undertaken. Today, Joe will provide an overview of the process to revise and update these ranges, and will present revised reference ranges for some of the core soil quality indicators used in State of the Environment monitoring. Now, as with all of our webinars, we do encourage questions and participation via the chat function, so please put your questions in there. And just a reminder that this session is being recorded and will be shared via our networks. At the end of Joe's presentation, we will do some Q&A live, but I am conscious of time, so for those that we don't answer live today, we will answer post the event and send those out. So without further ado, please sit back and relax, and I'll hand over to Joe.
Thanks, Tegan. Just following on from that, I'm going to give an overview of this MFE funded project that's been undertaken by, as a cross-CRI project. As mentioned, there's been a substantial amount of data and research that's been undertaken since the soil quality indicators were originally developed. This particular project sort of builds on an initial review which looked quite specifically at how the previous provisional values had been developed and what changes had been done over time. This is the fantastic project team that has been contributing to this work that was started in about May of last year. So feel free to also reach out to any of the individuals to follow up with any specific questions. In terms of the project objectives, it is that building on that significant amount of data to look at revise and propose new target values, target ranges for soil quality indicators used in State of the Environment reporting. A lot of these indicators are put out in the NEMS, in the associated NEMS. Probably a really clear, unstated project objective is really providing greater transparency on the basis and the interpretation of these numbers that are often used. And these are the specific indicators that are covered, the 7 core indicators plus also hot water extractable carbon, which has been proposed as an alternative for anaerobically mineralizable N. There's not enough time to go through all the detail of the individual indicators, so I'll be focusing on total carbon, Olsen P and macroporosity in the presentation today. Just as a bit of an overview of those different indicators, there's a description of what they actually kind of cover. There's both production and environmental outcomes associated with each of the indicators, and what we try to do is kind of balance both those production and environmental outcomes. So in terms of how the project was done, there was a targeted literature review that was undertaken looking at both national and international data. There was an initial workshop that sort of scoped the broader use of numeric criteria, kind of looking a little bit beyond both what could be done for the State of the Environment reporting, but more broadly how indicators could be used. There was following on from that, there was a substantial amount of data analysis that was done looking at Olsen P to revise numbers, and there was workshops and also developing the specific criteria. And then the draft report from this work is due to MFE in mid-April, towards the end of April, and a final report in 31st of May, and then all will be available after that. So in terms of the targeted literature review, the focus was for the national work was really on identifying published studies or data sets that could be used to inform the revision. The international focus was on those studies and getting up-to-date information on how targets and thresholds have been set internationally. The Environment Agency of Europe's got quite a nice one that came out into 2023, which kind of builds on a lot of the EU directives for soil health. The US-based comprehensive assessment of soil health has a really good kind of outline of the approaches that they use to develop numeric criteria, which fundamentally looks at the distribution of results from monitoring and developing those into a particular score. So these were all sort of some of the background information that was used to look at how we then might go into analysing the existing data. So this slide here just gives a bit of a snapshot of the data that we looked at. And I mean, one of the key things which we noted was that there's actually few limited studies that actually link soil quality to environmental outcomes. When we're talking about environmental outcomes, it's particularly water quality is a key one that comes up, and then increasingly greenhouse gas emissions are another consideration as well. There's a lot of data and data sets that provide information on the state, and with all of these different studies, there's a differing amount of data for the different indicators. From the data sets that provide information on the state, the key ones that you can see there with the asterisks, they form what we've termed the baseline monitoring data set. And that will mean more when I go through the next slides. Probably a key thing is that we're proposing a change in terminology, and specifically the use of reference range rather than target range. And that comes about because it's a more accurate description of how these ranges are being used, and that they're a range of values that are being used to provide context for individual results. But also importantly, there's not necessarily a robust basis for inferring that the range is a target to aim for. A focus that we're doing, the other aspect is that the interpretation of how if results fall outside of that reference range can vary depending on the basis of that reference range. And in terms of how the reference range is determined, that was based on an evaluation of the existing data, as well as considering what's the logic for interpreting these different values. And if we're looking at environmental outcomes, what factors actually influence that, what information is available for the soil health of the soil in relation to those different indicators. So this just gives an overview of the different approaches that we've used for the different indicators. So some is more of what's termed a sort of a fixed approach, and that's a constant value based on available research and knowledge, and kind of stratified or grouped as is required. And so that was used for pH, Olsen P, and also a minimum carbon percent for cropping soils. Another approach that was used for macroporosity and bulk density is a comparison to a reference situation, and in this we've used it for under fence line data and also undisturbed forestry sites. And then the bulk of the indicators are using what we call a distribution-based approach, and this is based on using the baseline monitoring set and using a range, and in particular the 10th to the 90th percentile of the baseline monitoring data set for different land uses and soil orders or groups of soil orders. This is a little bit of a snapshot. It's a kind of a busy slide, but the main point of this is just to note that there are, for a specific indicator, there can be different approaches used depending on the land use. So if you're looking at pH and Olsen P in particular, then we've a fixed approach has been based on the agronomic recommendations stratified by land use. Then for urban and indigenous vegetation land uses, it's been more of a distribution base. So that just gives an illustration of the different approaches that have been used. Going more specifically into Olsen P, as we highlighted, it has remained being focused primarily on agronomic recommendations, largely because there's too many factors that influence the loss of P to waterways for that to be the primary driver for setting Olsen P criteria. We did look quite closely at whether we could set values based on water quality. But I mean, this kind of gives a bit of an illustration of the various factors that influence water quality and also leaching into groundwater. There's a kind of an identified relationship between the anion storage capacity or the P retention of soils, with higher P retention resulting in lower loss. So we've considered that in a qualitative manner in the numbers. And then when we looked at some of the flux meter studies of the relationship between soil Olsen P and loss of dissolved reactive phosphorus, there's no clear relationships in that either. So these were some of the background data analysis that we did, but ultimately we've ended up working with the agronomic recommendations. So these were largely based on industry criteria and kind of like grouping across, incorporating the ranges that are specified in a lot of the handbooks, and for things like indigenous vegetation, there's no recommendations. So, and the same with exotic forestry, there's a limited amount point around the exotic forestry criteria. They often don't use Olsen P as an indicator for P in that land use. Olsen P is also a little bit complicated and causes a lot of confusion when you're looking at the numbers. Probably a key point to note is that it can be measured both in a volumetric manner and a gravimetric manner. The volumetric approach is used by a lot of the commercial labs, and that's basically based on a scoop of soil that is then analysed. It can be converted to a gravimetric value based on lab-based volume weight measurements. And a key point is that a lot of the production responses are measured against volumetric measures. A lot of the early work and a lot of research work is based on gravimetric analyses where a known mass of soil is analysed, and the National Environmental Monitoring Standards also specifies the use of gravimetric values. So to kind of balance this, the quantifiable responses being based on volumetric measures, but meeting the requirements of the NEMS being gravimetric measures, then we've converted the values using relationships that were identified in this paper here. And whilst you can get specific conversions of volumetric measures to gravimetric measures using volume weight, you often don't have that information for the previous work. So these are derived relationships based on a lot of empirical data. We did also adjust for depth adjustment for the pastoral soils, because the recommendations are based on 7.5 centimetres, but stated the environment monitoring is based on 10. For cropping soils, because those are considered to be well mixed within the top 15 centimetres, then those values haven't been adjusted. This is a busy slide. I'm not expecting you to take it kind of in, but this just gives you an illustration of the influence of soil order on the Olsen P values when it's converted from the volumetric to the gravimetric. At the lower Olsen P end, then they tend to be, there's not much difference, but there's a greater amount of difference that's noted at the higher end. And particularly for the vegetable cropping sites where there is a higher Olsen P that can be required for growing different crops, then looking at things like the P retention for soils, the proximity of those sites to waterways, the potential for leaching are factors that should be looked at when you're getting the higher Olsen P values. So in this context, those higher ends are a trigger for looking at the potential for water quality impacts to occur. Macroporosity, this is based on a very limited data set of samples from a combination of untreated or under fence line pastoral sites, and then a limited data set for undisturbed forestry sites. A really key point on why we didn't use the baseline monitoring set is based on individual studies which identify potential impacts of macroporosity. Then the information that we're finding is was indicated quite degraded land uses. So we've considered it, more as a reference site and looking at what the potential should be, for those different land uses. And probably a really critical point, and in some ways, more critical than the numbers, is the fact that different soils are less or more or less resilient, to compaction and the potential to recover from compaction. So I've just listed there what soils are, more sensitive to compaction issues and so less likely to recover, and then more resilient. Because of the limited data points that we've got for a lot of the individual soil orders, then we've aggregated that up to provide those reference ranges that you can see there. And as you can see, they're quite different for pastoral versus most other land uses, and then forestry. This image here just gives an indication of the variation that can occur over timeframes and over years, for macroporosity. And one of the key things that you're trying to pick up with this monitoring is whether that's changing over time. And so here you can see with the cattle sites, there is an ongoing degradation or a loss in macroporosity over time, and so sometimes that will be more relevant to be looking at than the actual numbers. In terms of total carbon, these are the numbers. Once again, a busy slide, but just wanted to give a snapshot of the variation that you get, and the fact that where allophanic soils come out as a different reference range to all other soils. We have looked quite hard at whether there were any other specific soil orders, such as granular soils, that could be pulled out of the existing data, but they've all ended up being aggregated there. The low the 2% of in the reference range for cropping soils is can be of concern to people, and it's probably important to note that this reference range, the lower end of this reference range has been bumped up, if you like, to this 2% value, which is based on a global meta-analysis study that looked at the relationship between soil carbon and a whole bunch of factors in cropping soils. So those factors include irrigation, fertilizer application, and what they found was that globally, below 2% carbon, then you do get an increased yield response, but it tends to flatten off after that period of time because irrigation fertilizer has a greater influence. So that's the rationale for that 2% value. And that being bumped up, from what the actual distribution of the 10th percentile would be. It's also really, useful to bear in mind some current work that's been going on by Sam McNally and Mike Beer as well, which looked at sort of, the saturation deficit of soils based on mineral surface area. And I think, with a little bit more time, then that's also useful to consider that, that deficit in terms of, better informing where we might be trying to aim for in terms of soil carbon values. Another key point that we've really tried to emphasise in this work is a better understanding of what the meaning is if numbers fall out of the reference range, depending on how they've been developed, and whether you're looking at that trend over time is for an individual site is more informative in terms of improving the soil quality at that site. Another approach that we're using is also the use of a traffic light colouring for the tables to give a more rapid assessment of, do I need to do something or do we not? And this is where you sort of see for things like, cropping and orchard soil, then because of that low carbon side of things, then there's a greater impetus to look at, what are the management actions that could be taken to improve, the soil carbon in those soils. So one thing which came out of this is, despite the substantial amount of research, that's gone on and monitoring, is we're not actually much further advanced in our ability to develop thresholds and quantitative basis than the early 2000s. We do have a better understanding of some processes, but we also recognise that there's a lot of factors that can influence, particularly environmental outcomes such as water quality. A really key point is that, if we're actually serious about developing numbers based on linking these soil quality, indicators to outcomes, is we actually need to do targeted research. this work plus other studies, and have done a really comprehensive analysis of using the existing data, and often what comes out of it is that you can't repurpose the information that's existing there, so we're still limited. More specifically, we need better data, a more extensive data set for those macroporosity and bulk density values. I think there's further work on carbon in granular soils that's probably warranted, particularly for the cropping soils. It's likely that modelling approaches are going to be the best, most effective way to actually get a better connection between the soil quality indicators and environmental considerations. We also need to look at what the relative influence of the soil quality parameters are on those outcomes that you might be looking at in relation to other factors as to where the emphasis is required. And just really want to highlight this is that the key issues that were identified in the early 2000s, which is reduced macroporosity, excess Olsen P, and low carbon in cropping soils, still remain the key issues today. And so there's a real need to consider how we use this information plus our other knowledge that comes through to affect positive changes in soil quality. And that's me. I'll hand back to you, Tegan.
Thank you, Jo, for sharing that today with us. A fantastic presentation. We have a good number of you online. Great to see the hands claps. Very quiet on the questions out there, team. So feel free to put some questions into the chat for Jo. I'm sure you should have some questions. Just give you a moment for that. While we're waiting for some questions to come through, Jo, really exciting research you've been doing and work you've been doing. What's next on the horizon, perhaps, while we wait for some more questions to come through?
Finishing the reports with the team. And then it's really up to, MFE working with the regional councils as to where this work goes on. There is another related EnviroLink Tools project, which is looking a little bit more at the implementation and approaches to the soil quality indicators, and so some fact sheets and information like that will come through that project as well, which will help support the narrative interpretation for these soil quality indicators.
Fantastic. And we have had a question come through. All right, in addition to physical and chemical proxies of soil health, microbial measures and have been discussed as potential indicators of soil health in certain contexts. Has there been any movement towards including these metrics, and is there any plan to incorporate them in the near future?
So it's probably important to point out that this project was specifically focused on the indicators that were covered, that we covered. I mean, the hot water extractable carbon, and the anaerobically mineralizable N are deemed sort of, biological indicators of, of one sort. The anaerobically mineralizable N is based on, soil and incubation, so that the microbial processes can work. There's correlations between the hot water extractable carbon and AMN in relation to microbial biomass and activity. Imperfect biological indicators, and it's fair to say that nationally and internationally there's a lot of focus around trying to get good biological indicators. As I mentioned, it wasn't within scope of this project to actually look at alternative indicators, but the parallel project, the EnviroLink Tools, bringing together more research on biological indicators is covered in that one.
And I think you might have answered one of our other questions. Hot water extractable carbon, often connected as a proxy. Can you please comment on this? Yeah.
So that is is included in these reference ranges. For this work.
Question: have these already been published or adopted? How can we access them?
We still need to submit the final draft, a draft report to MFE in mid-April, and the final report is due at the end of May, and then it will be up to MFE as to when they publish that online.
Excellent. Just working through the last. Has there been any work with agronomists happening, collaborative learning?
I'm not sure what context that might be in, but I think it does relate to, how these numbers are used and taken up. I mean, at the moment, I think they're used for state of the environment reporting, and I think a point that's really useful to bear in mind is that these are there's a bunch of monitoring sites that are monitored every 3 to 5 years, depends on the land use as to what frequency, and then reported on in the context of state of the environment monitoring. If you were to use numbers more for the purposes of managing your land, then you need the information a little bit more immediately, and it depends a lot more on the specific crops that you're going. I mean, I think overall, as for New Zealand Inc., producers, councils, central government need to be working together to develop, kind of a framework for how we manage, soil health and ensure that, primary production is being managed. And we're supporting, our primary production going forward, as well as managing the resource.
Fantastic. And last question: has there been any thought into using looking into other stresses such as pesticides or increasing use of plastic material in agricultural practices?
Yeah, that was outside the scope of this project, and is certainly some of the information that needs to be considered going forward.
Fantastic. Just check my other chat because we've got 2 threads happening. Were the data sets and correlations corrected? Many overseas studies often have different soil sampling depths.
Yeah, so the baseline monitoring data set that we've used is all based on 0 to 10. 0 to 10 sampling depth. So we didn't need to do the correlation for those results. But as mentioned for Olsen P, there was a depth correction for the recommendations based on 7.5 centimetres versus the SOE of 10 centimetres.
Fantastic. Thank you, Jo. That's all the questions we've got in. Please still keep posting them. We can answer them once this webinar is completed. As said at the start of the recording, this has been recorded. We will distribute this via the network soon after this webinar has finished, as well as a written copy of the questions and answers. Just a reminder that the next Manaaki Whenua Link Online webinar is scheduled for next week. The topic is covering mitigating greenhouse gas emissions from drained peat, and we look forward to you joining us for that one. Otherwise, on behalf of the team at Manaaki Whenua, thank you for joining us today. Ka kite.